Good day, everyone. My name is Mark Edsel Biberhami. I am the Chapter 6 first reporter, the normal distribution. The normal distribution topics, and my topics is introduction, the normal distribution, the standard normal, and finding areas. The normal distribution objectives. 1. Identify the properties of normal distribution. 2. Identify distribution as symmetric or skewed. 3. Find the area under the standard normal distribution given various z values. Introduction. Random variables can be either discrete or continuous discrete variables, and their distributions were explained in Chapter 5. Recall that discrete variables cannot assume all values between any two given values of the variables. On the other hand, continuous variables can assume all values between any two given values of the variables. No variable fits a normal distribution perfectly, since a normal distribution is a theoretical distribution. However, a normal distribution can be used to describe many variables because the deviations from a normal distribution are very small. This concept will be explained further in section 6-1. Normal distributions. The normal distribution, also known as the Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than data far from the mean. Normal distributions. In mathematics, curves can be repeated by equations. For example, the equation of the circle shown in figure 6-2 is x2 plus y2 equals r2, where r is the radius. A circle can be used to represent many physical objects, such as a wheel or a gear. A normal distributions. If a random variable has a probability distribution whose graph is continuous, bell-shaped, and symmetric, it is called a normal distribution. The graph is called a normal distribution curve. Suppose one normal distributed variables has mean equals 0 and sigma equals 1, and other normal distributed variables has mean equals 0 and sigma equals 2. As you can see in figure 6-3a, when the value. Normal distributions. Graph and examples na siya. A. Same mean but different standard deviation. B. Different mean but same standard deviations. Okay. Sa A, kay ang iyang mean kay 0. But kuan siya, different sila og standard deviation kay lahi sila og ka wide danon og ka gitas-on. B. Different mean but same standard deviation. Lahi na sila og standard deviation. Lahi na sila og mean. Kay ang mean sa blue kay 0 og ang mean sa brown kay positive 2. Pero same na sila og standard deviation. Kay para sila og ka wide og para sila og ka gitas-on. Objective 1. Identify the properties of a normal distribution. Of the standard deviation increases, the shape of the curve spread out. Of one normal distributed variables has mean equals 0 and sigma equals 2. And other normal distributed variables has mean equals 2 and sigma equals 2. Then the shape of the curve are the same, but the curve with mean 2 moves 2 units to the right. See figure 6-3b. Objective 2. Identify distributions as asymmetric or skewed. Right of the mean, the distribution is said to be a negatively or left skewed distribution. The mean is to the left of the median, and the median and the mean are to the left of the mode. The standard normal. The standard normal distribution is a normal distribution with a mean of 0 and standard deviation of 1. The standard normal distribution is centered at 0, and the degree to which a given measurement deviates from the mean is given by the standard deviation. The standard normal. Since each morally distributed variable has its own mean and standard deviation, as stated earlier, the shape and location of these curves will vary. In practical applications, then, you would have to have a table of areas under the curve for each variable. To simplify the situation, statistics use what is called the standard normal distribution. Objective 3. Find the area under the standard normal distribution given various z values. To find the specific area under a normal curve, find a z-score of the data value and use a z-score table to find the area. A z-score table is a table that shows the percentage of the values or area percentage to the left of the given z-score on a standard normal distribution. Positive z-score or a positive skewed distribution has a long tail on the right side, which means that there will be frequent small losses and few large gains. Here are the mean greater than median and median greater than mode. The extreme values affect the median the most, which is pulled to the right. Negative z-score or a negative skewed distribution has a long tail on the left side, which means that there will be frequent small gain and few large losses. Here the median less than mean less than median and median less than mode. The extreme values affect the most, which is pulled to the left. Finding area. Area is defined as a total space taken by a flat 2D surface of the shape of the object. Take a pencil and draw a square on the piece of paper. It is a 2D figure. The space of the shape takes up on the paper is called its area. Now, imagine your square and made up of smaller unit squares. Finding areas. Finding areas under standard normal distribution curve for the solution of problems using the standard normal distribution. In two-step process is recommended with the use of the procedure table shown. Finding areas under the standard normal distribution curve. The two steps are as follows. Step 1. Draw the normal distribution curve and shade the area. Step 2. Find the appropriate figure in the procedure table and follow the directions. To the left of any z values, look up the z value in the table and use the area given. Two, to the right of any z-value, look up the z-value and subtract the area from 1. 3. Between any two z-values, look up both z-values and subtract the corresponding areas. And that is my report. Thank you.